Hi, this is Mrs. Rodriguez, your algebra teacher. This video is a review for the Chapter 9 test that's coming up. These problems are from the practice test that can be found in your textbook on page 611, okay? So there's also a couple extra ones in there that were, no, actually, these are all from the practice test, okay? All right, so what I recommend that you do is that as you watch this video, when a problem comes up, please pause the video, try to solve the problem yourself first, and then play the explanation. And if you get the problem correct, great, move on to the next problem. If you get the problem wrong, hopefully my explanation makes sense and you figured out what your mistake was. And then if you get to the end of the video and there's a couple problems that you did not understand my explanation, and you're still confused as to how to solve that type of problem, please call, text, email me, or stop on my office hours, and I would be happy to go over those problems with you. Okay? All right, so let's go ahead and get started. So first section talks about graphing quadratic functions, okay? And a quadratic function can be described by an equation of the form y equals ax squared plus bx plus c, where a is not equal to 0. And you need to know the equation for the axis of symmetry, which is x equals negative b over 2a, okay? So here it says, find the equation of the axis of symmetry, the coordinates of the vertex, and identify the vertex as a maximum or minimum value. Okay, so first thing we're going to do is find the axis of symmetry. Okay, so remember, axis of symmetry, we use the equation x equals negative b over 2a. Remember, the value in front of x squared is equal to a, so a is equal to 2. The value in front of x is equal to b, so b is equal to negative 3. And then the value of c is the constant here, which is positive 1. Okay, so now I'm going to plug in my values in for the equation for the axis of symmetry. So x equals negative b, which is negative 3, and then 2 times a, which is 2. So I've got negative times negative, which is positive, so that would be a positive 3, and 2 times 2 is 4. So x is equal to 3/4. Okay, so that is my equation for the axis of symmetry. Okay, then it says to find the coordinates of the vertex. So I plug this value in to the equation here and solve for y. Okay, so I've got y equals 2 instead of x. I'm putting 3/4 squared minus 3 instead of x. I'm putting 3/4 plus 1. Okay, so y equals 2 times 3 to the second power, which is 9, 4 to the second power, which is 16, minus 3 times 3/4, so 3 times 3 is 9, and 1 times 4 is 4, 9/4, and then I still have this plus 1, okay? So then I'm going to multiply 2 times 9 16ths. Okay, so that's 2 times 9, which is 18. 1 times 16 is 16, minus 9/4. But I want my denominators to be the same, right? So I want my denominator to be 16. So 4 times 4 is 16, so I'm going to multiply 9 times 4, and that's 36. And then I'm going to add 1. So 18 16ths minus 36 16ths equals negative 18 16ths. Now I still need to add 1, but I want a common denominator. So 16 divided by 16 is 1, right? So negative 18 plus 16 is negative 2. My denominator stays the same, and I can simplify by 2, and I get negative 1/8. So y is equal to negative 1/8. So my coordinates for my vertex, when x is 3/4, then y is equal to negative 1/8. Okay, so this is my vertex. Okay, and then the last part of the problem says identify the vertex as a maximum or a minimum. So if I'm looking at this equation here, I know my parabola is going to be open upwards, right? So if it's open upwards, then I'm going to have a minimum value. Okay, so this vertex is the minimum value. Okay. All right. So let me clear that. So here it says determine whether the function has a maximum or minimum value. So this is x squared. It's going to be open upwards. So again, I'm going to have a minimum value. If it was open downwards, it would have a negative in front of the x squared. Okay, and it would have a maximum value, right? It would have a highest point. This doesn't have a highest point. It just keeps going in both directions, so it only has a lowest point as a minimum value, okay? So this one has a minimum value. Then it says to state the maximum or minimum value. So I need to find the vertex, okay? So again, I'm going to use this x equals negative b over 2a. So x equals, here a is 1, b is negative 7, and c is positive 6. So negative b, which is negative 7, over 2 times a, which is 1. So negative times negative is positive, and 2 times 1 is 2. So x is equal to 7 over 2, or that's 3.5 as a decimal, okay? So then I plug that in for x into my equation. So I've got y equals, instead of x, I put 3.5 squared minus 7 times 3.5 plus 6. So 3.5 squared is 12 and 25 hundredths minus 7 times 3.5, which is 24.5 plus 6. So I would subtract 12 and 25 hundredths minus 24 and 5 tenths, which is 12 and 25 hundredths, and negative 12 and 25 hundredths plus 6. So y is equal to negative 6 and 25 hundredths. So that means my vertex, when x is 3.5, y is negative 6 and 25 hundredths. Okay, so my minimum value is going to be negative 6 and 25 hundredths. That's my y value. Okay, so minimum value equals negative 6 and 25 hundredths. Okay, then I need to find the domain and the range. So remember, domain are the x values, okay? So this parabola is opening upwards. It's just going to keep going in either direction. So my domain is going to be all real numbers. And then my range, remember, those are my y values, okay? So y, my lowest point, is negative 6 and 25 hundredths. So all of my y values have to be higher or greater than negative 6 and 25 hundredths. So they have to be greater than or equal to negative 6 and 25 hundredths. Okay? So that's my domain and my range. All right, so then this next part talks about solving quadratic equations. There's different ways, by graphing, by completing the square, or using the quadratic formula, okay? Also, specifically this lesson 9-3, we're gonna look at a problem like this, talks about how quadratic functions are transformed, right? So if we add a value of c to x squared, then the graph is going, if the number is positive, the graph goes up that many units. If it's a negative, it goes down that many units. And then if we have a value in front of x squared, then that compresses or expands the graph vertically, okay? All right, so you're gonna have some questions where it says, it asks you to describe how the graph of each function is related to the graph of f of x equals x squared. So that's your parent function, okay? So if we take our parent function and we subtract 5, then it is translated down 5 units, okay? So whatever the parent function is, right, that starts at the origin, okay? So this one, it would move it down 5 units, okay? So let's say this is 5, so then it would be like this, okay? All right, so then g of x is equal to negative 3x squared. So we've got a value in front of x squared, okay? So that means it's going to be stretched vertically, okay? And also, since there's a negative here, what that does is it flips our parabola this way, okay? So it's reflected over the x-axis, okay? That's the other translation there, okay? And then the last one is 1/2 of x squared plus 4. So now we still have a value in front of x squared, but it's less than 1. So it is compressed vertically, okay? And then also, since it's got this plus 4, it's translated up 4 units. Okay? All right. So next section, or next problem says, which is an equation for the function shown in the graph? Okay, so this is taking into account what we're just talking about. So first of all, by looking at this graph, I see it's reflected over the x-axis, right? Oops. It has been flipped, right? It's not a regular parent function like this, okay? So I know that the value in front of x squared has to be negative. So it cannot be b and it cannot be c because those both have a positive value in front of x squared. The other thing I notice is it doesn't start at the origin. It starts 2 units above the origin. So it's got to be 2 has to be added to this equation. And here, nothing is added, so it cannot be A, it has to be D, okay? So you will have questions like that when you're given a graph and you're asked for the equation. All right, so then you have to be able to solve equations, solve quadratic equations by completing the square, okay? So here we have number 12. It says to solve each equation by completing the square. All right, so first thing, I'm going to get my x squared and my 2x by themselves. So I'm going to move this over here. So I've got x squared plus 2x equals -5. So then I'm going to complete the square. So I'm adding something, a value to both sides of my equation. What value am I adding? Remember, I take the value of b, divide it by 2, and then square it. So b is 2. 2 divided by 2 is 1, and 1 squared is 1. So I'm just adding 1 to both sides here. So if I factor this, I get x plus 1 squared is equal to -5 plus 1, which is -4. Okay? Now, my next step is to take the square root of both sides, but the problem is I cannot take the square root of a negative. Okay? So that means there is no solution to this equation. Okay? No solution. Because I cannot take the square root of a negative, that gets into imaginary numbers, and I believe that starts in Algebra 2. Okay, you guys are in Algebra, so we don't have to worry about that just yet. Okay. All right, so next problem says to solve each equation by completing the square. Okay. All right, so here I'm going to solve this by completing the square. And so first thing I'm going to do is I'm going to add 6 to both sides. I want to get x squared minus x on its own, so I've got 6 over here. Then I'm going to be adding a value to both sides of my equation. So half of b is -1. Remember, it's b divided by 2 squared. b is -1. Okay, so -1/2 squared is positive 1/4. So I'm adding 1/4 to both sides, or 0.25. Okay, so I'm going to go ahead and write them as in decimal form. Okay, so this would be 25/100. 25/100. So when I factor this, this is going to be x minus 5/10 squared equals 6 plus 25/100 is 6 and 25/100. So then I would need to take the square root of both sides. So I get x minus 5/10 is equal to plus or minus 6 and 25/100. So I have x minus 5/10 equals 6 and 25/100, or x minus 5/10 equals negative. Oh, sorry. Not 6 and 25/100, the square root of 6 and 25/100, which, if you do that in a calculator, is 2.5. So this is supposed to be 2.5. Sorry about that. So it's either going to be x minus 5/10 equals 2.5 or x minus 5/10 equals negative 2.5. Okay. All right. So here I would then add 5/10 to both sides. So x equals 2.5 plus 1/2 is 3. And here I would add 5/10. So x is equal to negative 2.5 plus 1/2 is going to be negative 2. So my solutions are 3 and negative 2. Okay. All right. Next problem here. Now here, we're going to set this equal to 0 first. So I'm going to add 6x to both sides. So I've got 2x squared plus 6x minus 36 equals 0. Okay, so now at this point, completing the square only works if the leading coefficient in front of x squared is 1. So what I need to do is divide both sides of my equation by 2. So then I've got x squared plus 3x minus 18 equals 0. So now my leading coefficient is 1. So then what I'm going to do is I'm going to add 18 to both sides. So I've got x squared plus 3x is equal to 18. Then I need to complete the square, right? So x squared plus 3x plus something is equal to 18 plus that same something, okay? So remember, I've got to take b divided by 2 and square it. So b is 3, got to divide it by 2 and square it. So 3 squared is 9 and 2 squared is 4. So that would be 9/4 that I'm adding to both sides. Okay? So then when I factor this, this is x plus 3/2 squared is equal to, okay, 18 plus 9/4. I can do that. Remember, pre-algebra, okay? My denominators need to be the same, so I've got to multiply here. So 18 times 4 is equal to 72. So I take 72/4 and add 9/4, and that's 81/4, okay? And then, so I take the square root of both sides. So I've got x plus 3 over 2 is equal to plus or minus the square root of 81 is 9, and the square root of 4 is 2. Okay, so I've got x plus 3 over 2 equals a positive 9 over 2, or x plus 3 over 2 is equal to negative 9 over 2. So I'm going to subtract 3 over 2 for this equation. So x equals 9 over 2 minus 3 over 2 is 6 over 2. 6 divided by 2 is 3. So x equals 3 here. And then I would subtract 3 over 2 here. So I've got x equals negative 9 minus 3. Add the opposite. That's negative 12 over 2. And negative 12 divided by 2 is negative 6. Okay, so those are my two solutions there. All right. So next problem, our next section talks about solving by using the quadratic equation. Okay. So here it says solve by using the quadratic equation. So for the quadratic equation, we need to know the values of a. So a is equal to 2, b is equal to 1, and c is equal to negative 15. Then we're just plugging that information into our equation, okay? So our equation is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so I'm going to plug in that information. So x equals negative b, which is 1, plus or minus b, which is 1, squared minus 4 times a, which is 2, times c, which is negative 15. And it's the square root of all that, divided by 2 times a, which is 2. Okay, so I got x equals negative 1, plus or minus 1 squared is 1, minus 4 times 2 is 8, times negative 15. Just doing one step at a time so you can follow along. 2 times 2 is 4. So then I've got negative 1 plus or minus, and I need to multiply before I subtract here. Okay, so negative 8 times negative 15 is going to be positive 120. I still need to divide that by 4. Okay, so I've got negative 1 plus or minus 1 plus 120 is 121 divided by 4. Negative 1 plus or minus the square root of 121, that's actually a perfect square. That's 11, right? 11 times 11 is 121 divided by 4. So my solution is x equals negative 1 plus 11 divided by 4, or x equals negative 1 minus 11 divided by 4. So I'll solve this one first. Negative 1 plus 11 is equal to 10 over 4, which is equal to 2.5. So that's 1, 2.5. Okay, and then negative 1 minus 11 is equal to negative 12 over 4. Okay, and negative 12 divided by 4 is negative 3. Okay, so those are your answers there. All right, and here we have another problem that's asking you to solve using the quadratic equation. So first thing, we need to set it equal to 0. So I need to add 15 to both sides. So x squared minus 10x plus 15 equals 0. So a is equal to 1, b is equal to negative 10, and c is equal to positive 15. Okay, so now we plug that into our equation. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so I plug in my values here. So x equals negative b, which is negative 10, plus or minus b, negative 10 squared minus 4 times a, which is 1, times c, which is 15. And that's all the square root divided by 2 times a, which is 1. So negative times negative, that's positive. 10 plus or minus negative 10 squared is 100. Minus 4 times 1 is 4. Times 15. 2 times 1 is 2. So x equals 10 plus or minus 100 minus 60. All of that divided by 2. So x equals 10 plus or minus 100 minus 60 is 40 divided by 2. So I've got two possible answers here. So x is equal to 10 plus the square root of 40 divided by 2, or x is equal to 10 minus the square root of 40 divided by 2. So 10 plus the square root of 40 is about 16 3/10. Divide that by 2, and I get 8 1600ths, and it says to round to the nearest tenth, which is 8 2/10. Over here, 10 minus the square root of 40 is about 3 6800ths divided by 2. X equals 1 8300ths. So if I round it off to the nearest tenth, it's 1 8/10. Okay. All right, and then another section talks about analyzing functions with successive differences. Okay, so talks about if you have the same difference, then it's a linear function. If the second difference is different from the first, then it's going to be a quadratic function. And if you have a common ratio, then it's an exponential function, right? So here it says the table shows the number of car club members for 4 consecutive years after it began. Okay, so first thing it says determine which model best describes the data. So is it linear, quadratic, or exponential? Okay, so I'm looking at my y value, which would be my members, and to go from 10 to 20, I either add 10 or I can multiply by 2, right? 20 times 40, or 20 times 2 is 40, and 40 times 2 is 80, and 80 times 2 is 160. So it looks like this is going to be an exponential function, right? Because it has a common ratio here, okay? And then it says to write a function that models the data, okay? So for an exponential function, you use the equation y equals a times b to the power of x, okay? And then b is the common ratio, okay? So I know a times 2 to the power of x, okay? So I need to find the value of a, okay? Now, I know that when x is equal to 0, my y value is equal to 10. So I can plug in to this equation 10 equals a times 2 to the power of 0. And the reason I'm picking 2 to the power of 0 is because anything to the power of 0 is just 1, right? And a times 1 is a, so that helps me figure out what a is, right? So now I know from my equation, y equals a, which is 10, times b, which is the common ratio, 2 to the power of x, okay? So that is my equation there, okay? And then the last thing, it says predict the number of car club members after 6 years. Okay, well, I've got my equation, so now I'm just plugging in 6 for the number of years, which is x. So y equals 10 times 2 to the power of 6, okay? So 10 and 2 to the power of 6, 2 times 2 times 2 times 2 times 2 times 2 is 64, okay? So 64 times 10 is 640 members, okay? And that was part C, okay? All right, here it says, talks about special functions, okay? So we've got these, the greater integer functions, and we've got absolute value functions, okay? So it says to graph this function here, the absolute value of x minus 1, okay? So recall that absolute value has to be greater than, has to be positive, right? So if x minus 1, we set that equal to 0, I would add 1 here, x equals 1. So I know that my vertex, or the lowest value, is going to be where x is equal to 1, okay? So I'm going to create a table. Oh, I should put f of x. Okay, so if I plug in 1, I know when x is equal to 1, f of x is going to be equal to 0, right? 1 minus 1 is 0. Okay, so that means when x is 0, I'm sorry, when x is 1, y is 0. So that's a point there. So I'm going to plug in a 2. So I take 2 minus 1. Okay, 2 minus 1 is equal to 1, and the absolute value of 1 is 1. So when x is 2, y is 1. Okay, I can plug in a 3. So 3 minus 1 is equal to 2. The absolute value of 2 is 2. So when x is 3, y, or f of x, is 2. And I want some, I know this is absolute value function, so I know it's going to be V-shaped. So I want some on the other side as well. So let's plug in 0. So if I have 0 minus 1, well, that's negative 1, and the absolute value of negative 1 is 1. So when x is 0, f of x is 1. And I'll just plug in 1, or negative 1, excuse me. So when x is negative 1 minus 1 is equal to negative 2, and the absolute value of negative 2 is positive 2. So when x is negative 1, while f of x is positive 2. So I can see that my V shape is going to look like this. Okay, and it's just going to keep going in those directions. Okay. All right, then here it says to graph each function. So here we have f of x, and we have two functions here. Okay, we have 2x minus 1 if x is less than 2. Okay, so I'm going to deal with that one separately. So f of x equals 2x minus 1, and this is where x is less than 2. So I'm going to plug in 2 for x, and this would be 4 minus 1, which f of x would be equal to 3. So when x is 2, f of x is 3, 1, 2, 3, but it has to be less than, okay? So I'm going to have an open circle there, okay? Don't fill that in, okay? So I know that my y-intercept, since this is in slope-intercept form, I can see that my y-intercept is at negative 1. So here's negative 1 right here. So that's going to be a point. And then my slope is 2. So it's going up to over 1, up to over 1 like that. But it wants it less than 2. So my line is going to go this direction, okay? And it's got, oh, come on, what are you doing? Okay, so it's going that direction, okay? So now I've got x minus 3 if x is greater than or equal to 2. So I'm going to plug in equals f of x. So I'm going to plug in 2. And then this ends up being negative 1, right? Now it says greater than or equal to 2. So when x is 2, f of x is negative 1. So this is going to be a closed circle because it's greater than or equal to 2. Okay? And here, my y-intercept is 3, but it wants the values greater than or equal to 2. So I'm not going to put anything to the left, right? It has to be greater than where x is equal to 2. But I know my slope is 1, right? There's a 1 in front of x. So up 1 over 1, up 1 over 1, up 1 over 1 like that, okay? So it's going to keep going this direction. Again, the reason I didn't put the y-intercept, even though what it says what it is, it only wants x when x is greater than or equal to 2. Okay, so it's only that part of the graph. Okay. All right, so that's all I have for you. Hopefully this review was helpful. Hopefully if you had any questions, some of them were cleared up. If you still had a few problems where you didn't understand the explanation, please call, text, email me, or stop by my office hours, and I'd be happy to help you with those. Okay, you have a great day.